Welcome to Gavin Fun Facts, where the world's strangest truths come to light. Ready to learn something unbelievable?
In the silence of the universe, long before humans existed, before forests, before oceans, before mountains, even before time could be measured, space was nothing but a vast, dark canvas filled with possibilities. There was no day, no night, no sound, no color. Only young stars glowed faintly, like tiny lanterns scattered across an eternal emptiness. And in one quiet corner of the Milky Way, an extraordinary story was beginning. Not a story about life, not a story about creatures, not even yet a story about planets. This story begins with something far simpler. Dust. Cosmic dust drifting through space, tiny, weightless, seemingly insignificant. Yet tonight, in the endless night of the primordial universe, that dust was beginning to gather, trying to become something that had never existed before. The gathering of the dust. Near the center of the Milky Way, exploding stars scattered their remains. Iron, magnesium, carbon, silicon, tiny bits of matter floating freely. Carried by the faint pull of gravity, the particles drifted slowly across empty space. But in one quiet region, that pull began to grow stronger. Dust thickened into a mist, mist condensed into clumps. Clumps spiraled into a swirling mass. Like a gentle, invisible wind, gravity pulled every grain inward, making the entire cloud twist and tighten. It took millions of years for this process to accomplish a single small step. But the universe never hurries. It simply watches and waits for new worlds to emerge from the void. When the world was still made of fire, as the mass grew, so did its gravitational power. Dust became pebbles. Pebbles became stones. Stones collided violently, melting, merging, and forming larger bodies. Across millions of years, this fiery mass took shape, a massive, molten sphere, glowing a fierce red. This was the first Earth, but nothing like the peaceful blue planet we know. There was no blue sky, no oceans, no land, no clouds. Only a giant glowing orb of molten rock, lava rivers, and explosive vents spraying steam and metal into the air. Its surface boiled, cracked, and reshaped itself constantly. It looked like a world forged inside a cosmic furnace, harsh, violent, unforgiving. And slowly, beneath the chaos, something essential began to form. Earth's crust. A thin skin of solid rock. Fragile, weak, but crucial, because everything that would one day live would depend on it. But just as Earth was beginning to cool, a catastrophic event arrived. An event so massive that it almost erased the planet's entire future. A Mars-sized object drifted into Earth's path, silent, unavoidable. Its gravitational pull locked with Earth's, drawing them together. And then, boom! A collision unlike anything imaginable today. Huge chunks of Earth's surface were blasted into space. Molten rock and vaporized metal scattered into orbit, forming a glowing ring around the young planet. For thousands of years, those fragments collided, merged, and gathered again. From the chaos, from the violence, from destruction itself, the moon was born. It slowly cooled, rounded, and began to orbit Earth, glowing softly in the endless night. The moon became more than a companion. It became Earth's stabilizer, its guardian of tides, its emotional anchor for every creature that would one day gaze upward. Without that collision, without that debris, Earth might never have had a moon. and life as we know it may never have emerged. Every time humans look at the moon, they unknowingly look at a piece of Earth's ancient body. When the sky began to weep, millions of years passed. Earth's crust thickened. Volcanoes exploded less frequently. Heat began to escape into space. Steam, trapped in the atmosphere, finally rose into the sky, forming the planet's first clouds. Not white, not soft, but dark and heavy, filled with ash, gas, and minerals. And one day, for the first time in the history of the world, rain fell. But this was not ordinary rain. It rained for thousands, hundreds of thousands, even millions of years. The first raindrops evaporated instantly on hitting the scorching ground, but the rain did not stop. It continued, pooling, cooling, softening the fiery world below. Droplet by droplet, the basins and craters formed by magma and meteoritic impacts filled with water, and the first oceans were born. The first waves rolled across the young planet, the first tides, the first whispers of water meeting stone. For the first time, Earth looked alive. The silent primordial sea. Imagine the first oceans, vast, dark, rich with minerals. No fish, no plants, no corals. Only shimmering black water beneath a red, volatile sky. But inside these silent waters, something was happening. Tiny chemical reactions, small bubbles forming, molecules meeting, breaking apart, meeting again, all in total darkness. And from these tiny reactions, something unimaginable was approaching. The beginning of life. But that belongs to another chapter, one that unfolds slowly, gently, and miraculously. For now, Earth remained young, still cooling, still forming land, still stabilizing its spin. But one truth had already been written. Earth was born, and it was ready for the long journey ahead. A journey that would bring ancient creatures, towering dinosaurs, the first mammals, the rise of humanity, and everything that would define the modern world. But tonight, as we close our eyes, let us imagine the young Earth, fresh from storms of fire, now sleeping beneath a dark sky while its new moon watches quietly. A world empty, but full of promise. When you imagine the Earth in a time so ancient it almost feels unreal, try letting go of every modern picture that usually comes to mind when you hear the word planet. During this early era, Earth was not a calm blue world, nor a home filled with forests, animals, or anything familiar. It was a wild place, wild in a way that nothing today can compare to. A massive sphere of molten rock slowly cooling down, wrapped in thick, rolling clouds that never stopped swirling. And beneath those dark layers, a great story was waiting to begin. For the first millions of years, Earth was in a truly hostile state. Its surface was covered in oceans of lava that flowed like rivers of fire, and its crust was unstable, constantly cracking and shifting. The atmosphere was filled with carbon dioxide, nitrogen, sulfur, ammonia, and other heavy gases. The sky never turned clear. It glowed a dull red from the fiery world below. Every corner of the planet was turbulent, and every moment pulsed with unimaginable energy. But despite the chaos and danger, that chaos was exactly what the planet needed, because from within it, something extraordinary was forming: the first oceans. As Earth slowly cooled, not quickly and not suddenly, but gradually, like a long exhale of a planet learning to exist, the thick steam that blanketed its atmosphere began to condense. The process happened on a scale beyond imagination. And then it started. Rain. Not rain for a day, not for a week, but rain for millions of years without stopping. Imagine a world where the sky never stops crying. Torrential downpours drenched the surface endlessly. Each drop carried minerals, energy, and the seeds of transformation. Water flowed, filled, and reshaped every crevice of the planet. And after an unimaginably long time, the lowlands and massive basins became filled with water. This was the birth of Earth's first ancient oceans, vast, dark, and full of mystery. They were nothing like the sparkling blue seas we know today. These oceans were dark brown or even black, thick with minerals, chemicals, and particles from volcanic eruptions. The sky above remained dim, filled with heavy clouds that only occasionally allowed weak sunlight to seep through. But still, these oceans were the perfect cradle, an immense container for the chemical reactions that would change everything. Deep in the ocean, near hydrothermal vents, cracks in Earth's crust that spewed hot mineral-rich water, an astonishing chemical symphony was unfolding. There, extreme temperatures met concentrated chemical energy. Small molecules collided, transformed, broke apart, and reassembled endlessly. It was as if the ocean was trying millions of combinations, searching for the one pattern that could spark something new. From this relentless cycle, something simple yet extraordinary emerged: molecules that could copy themselves. They were not life in the way we understand it, but they were the foundation of all life that would come later. These simple molecules became more complex. Some developed thin membranes that separated their inside from the outside world. And with that, the first living cells appeared. Single-celled organisms, without eyes, without sound, without consciousness. Just tiny bubbles carrying chemical instructions. But don't underestimate them. Even though they were fragile, they possessed something powerful: the ability to survive and multiply. In the dark and cold waters, these early organisms began to replicate. Each new generation came with tiny errors, small variations that accumulated over unimaginable spans of time. These small differences built the earliest structure of evolution. It was slow, subtle, and quiet, like a whisper shaping the destiny of the world. At this early stage, life depended entirely on chemical reactions around it. It didn't need sunlight. It only needed the Earth's own energy: heat, minerals, and molecular interactions occurring deep within hydrothermal vents. But one day, as Earth's atmosphere began to thin and sunlight could finally pierce through the surface of the oceans, life discovered a new opportunity. A few organisms developed pigments that could absorb sunlight, using its energy to create food. This process, photosynthesis, became one of the greatest turning points in Earth's history, because along with the energy it created, photosynthesis also produced something else: oxygen.
At first, oxygen was deadly. It damaged cellular structures and poisoned many early organisms. Countless forms of primitive life went extinct, but a few adapted. And from that adaptation, new pathways for living became possible. Oxygen spread through the oceans, then began filling the atmosphere. Slowly, over millions and millions of years, Earth's air transformed from a toxic mix into something far more balanced. The sky grew brighter, the oceans became clearer, temperatures stabilized. With oxygen in the environment, new and more efficient ways of generating energy became available. Organisms capable of using oxygen gained a huge advantage. They could grow, change, and evolve with far greater efficiency. This set the stage for life to become more complex, leading eventually to creatures much larger and more diverse. Imagine that era. On the surface of these ancient oceans were billions of tiny, invisible beings, each living a simple existence that looked unchanged for ages. Yet beneath that stillness, evolution was slowly shaping the future. Meanwhile, the planet itself also changed. Volcanic activity gradually decreased. Land masses stabilized. Early continents began drifting, colliding, and separating. Weather systems formed. Rivers and lakes appeared. Minerals circulated around the world. Everything worked together like a vast, delicate orchestra, forming the foundation of the world we know today. As you close your eyes tonight, imagine how quiet Earth must have been. No birds, no animals, no trees, only the wind moving across barren land and the low rumble of ancient waves. The world was still silent, but it was preparing itself, preparing for forests, animals, civilizations, and eventually people like you. Let the image of these ancient oceans calm your thoughts. Let the rhythm of the early Earth ease your mind into deep rest, because our journey is far from over. There are many more chapters ahead, stories of the first complex creatures, of life crawling onto land, of continents drifting apart and coming together, and of the long evolutionary path that shapes all life. Tonight, rest well. In the next chapter, our world will take its first steps toward a richer, more vibrant Earth. In the vast silence of Earth's early history, long before forests towered over the land or waves carved the edges of continents, our planet was nothing more than a swirling experiment of fire, water, and chemistry. The atmosphere was thick with volcanic gases, the oceans were dark and warm, and lightning repeatedly struck the surface of the young world. Yet from this chaotic and unforgiving environment, something extraordinary began to emerge, the earliest traces of life. The birth of life did not occur in a single moment, nor was it a dramatic event. It was a slow, almost invisible progression. Tiny reactions, small changes, and gradual formations that took hundreds of millions of years. Scientists believe that life began in the oceans, where the water acted as both a shield from the harsh environment and a laboratory for chemical evolution. Within these ancient seas, the fundamental ingredients of life, carbon, hydrogen, nitrogen, oxygen, and various minerals, began to combine in increasingly complex ways. At first, there were only simple molecules, drifting aimlessly in the warm waters. But over time, these molecules started forming chains and structures capable of storing energy and reacting with their surroundings. Some of these structures gained the ability to replicate themselves, and although they were not alive in the way we understand life today, they marked the transition from chemistry to biology. From these primitive building blocks emerged the first true cells, prokaryotics. They had no nucleus, no complex internal systems, and their shapes were unimaginably small. Yet, despite their simplicity, they possessed something revolutionary: the ability to survive, adapt, and multiply. These organisms fed on minerals and chemical energy from the oceans, thriving in environments that would kill any modern creature. For nearly 1 billion years, Earth was dominated solely by these microscopic beings. They formed massive colonies on the ocean floor, clung to hydrothermal vents, and spread throughout every corner of the primordial seas. Though individually tiny, collectively, they shaped the entire planet. One of the most transformative groups among them was cyanobacteria, the pioneers of photosynthesis. Through this process, they used sunlight to produce food, releasing oxygen as a byproduct. This oxygen slowly accumulated in the atmosphere, a change so dramatic that it eventually triggered the Great Oxygenation Event. At first, oxygen was toxic to many organisms, causing mass die-offs. But over millions of years, life adapted, and the atmosphere transitioned into one capable of supporting more advanced forms of biology. With higher oxygen levels in the oceans and atmosphere, life had new opportunities to evolve. Some cells merged, forming more complex structures with internal compartments. These were the first eukaryotes, organisms with nuclei and organelles that allowed for advanced functions. This leap in complexity opened the door to multicellular life. Over countless generations, cells learned to work together. They began forming simple tissues, then more specialized organisms. From small worm-like creatures to branching algae, life started experimenting with shapes, structures, and functions. The oceans became laboratories of evolution, filled with microscopic battles, cooperation, and survival. Everything that would eventually evolve, plants, fish, insects, reptiles, mammals, and humans, traces its roots back to these early, unassuming beginnings. The first cells may have been tiny and fragile, but they carried the spark that would one day build forests, fill the skies with birds, and shape civilizations. The birth of life was not loud. It was not sudden. It was a slow, steady unfolding, a quiet determination from nature to continue moving forward. And from the smallest cell, floating in a dark ocean, came the unimaginable diversity of life that inhabits Earth today.
In the long history of Earth, there is one period so astonishing that it feels as if the entire planet opened a box of wonders never imagined before. This era is known as the Cambrian Explosion, a moment when life, once silent, simple, and barely noticeable, suddenly transformed into a parade of extraordinary new forms. Before this era, Earth's life was mostly single-celled organisms or tiny creatures with barely any structure. But in a relatively short time, around 20 to 25 million years, life's diversity skyrocketed at a pace that has never been repeated. This chapter takes you into a time when Earth's oceans became the largest experimental stage in existence. Every second, every drop of water, every grain of sediment was a new experiment, and Earth seemed to rewrite the rules of life. From this moment emerged creatures that were unique, strange, magnificent, some even appearing as though they came from another world. The beginning of a biological revolution. Before the Cambrian explosion, life moved slowly. For hundreds of millions of years, single-celled organisms and simple creatures like sea sponges dominated Earth. But environmental changes sparked new opportunities. Oxygen levels increased significantly thanks to the tireless work of cyanobacteria from earlier eras, creating oceans and atmospheres more suitable for active organisms. Not only that, Earth's surface underwent tectonic shifts that changed the shapes of oceans, creating new environments, new currents, and new nutrient flows. This combination provided the perfect conditions for evolution to go wild. Under these circumstances, life didn't just survive. It grew with stunning creativity. During this time, body structures became more complex. Living creatures began to have mouths, eyes, legs, muscles, digestive systems, and even nervous systems capable of responding to the outside world. This was an enormous leap from previous life, which mostly consisted of floating bubbles of cells drifting through the sea. The first creatures to rule the seas. The Cambrian seas were filled with life forms that have never been seen again. Many of these creatures look like the product of a fantasy artist's imagination, yet they truly lived millions of years ago. One of the most famous is Anomalocaris, the top predator of its time. Though only about a meter long, it was a giant in that era. Its body resembled a massive shrimp-like creature equipped with long, grasping appendages to capture prey. With large, complex eyes, it was clear that vision was an essential factor in early evolution. Its swift movements cut through the water with a flexible body, like a biological weapon designed for hunting. Another bizarre creature was Opania, which scientists still consider one of the strangest animals to ever exist. Its soft body, 5 eyes, and long, trunk-like appendage in front of its mouth made it look like it came from another planet. Yet, Opania stands as proof that evolution once tried every possible shape in its quest for survival. Then, there was Hallucigenia, a small creature with long spines on its back and thread-like legs so strange that paleontologists once couldn't tell which side was up. Its name, inspired by its dream-like oddity, reflects how surreal its appearance was. Hallucigenia shows how wildly experimental evolution was during this period. Many creatures of this time have no modern comparison. Some had hard shells, others soft bodies. Some resembled worms, others displayed limbs, and some looked like hybrids between shrimp and insects. This diversity wasn't an accident, it was a sign that evolution was testing every possible body plan.
The rise of exoskeletons and body protection. A major innovation of the Cambrian period was the development of exoskeletons, or external body armor. Creatures like trilobites began experimenting with hard outer shells that offered protection and structural support. Trilobites became one of the most successful creatures in Earth's history, surviving for hundreds of millions of years before their eventual extinction. They first appeared in the Cambrian era and quickly dominated the oceans. With exoskeletons, creatures could grow larger, move more efficiently, and defend themselves from predators. This structural support helped create more advanced body features, including legs, antennae, and jaws. Evolution accelerated even more, and creatures adapted in countless ways. The first wars in the history of life. The Cambrian era was not only about growth and innovation, but also about competition. For the first time in Earth's history, creatures hunted each other, fled for survival, hid from danger, and fought to stay alive. This was the beginning of the evolutionary arms race. Creatures that could move faster, see better, or protect themselves more effectively had a higher chance of survival. Predators like Anomalocaris pushed other organisms to develop defensive strategies such as hard shells, camouflage, or the ability to burrow. This evolutionary arms race triggered the development of more sophisticated brains and nervous systems. Life was no longer just about floating. It became about strategy, speed, agility, and instinct. From here, systems that would eventually form vertebrate animals and land dwellers began to take shape. The early evolution of eyes and vision systems. One of the greatest evolutionary leaps of the Cambrian period was the emergence of complex eyes. Previously, creatures could only detect light and darkness. But during this era, evolution produced eyes with lenses, retinas, and the ability to detect movement. Light became both a weapon and a shield. Creatures with better vision could evade predators or find prey more easily. Trilobites, for example, possessed one of the earliest and most advanced optical systems, with eyes made of calcite, giving them impressive vision for their time. The presence of sight accelerated evolution, creating a world filled with dynamic interactions. The foundation of modern life forms. Although many Cambrian creatures looked strange and unrepeatable, this era was the birthplace of many modern body structures. This is when the world first saw early forms of annelid worms, which would become ancestors to many modern creatures, arthropods, the ancestors of insects, spiders, and crustaceans, early chordates, which would later evolve into fish, amphibians, reptiles, the dinosaurs, the mammals, and eventually humanity itself. The Cambrian explosion was the moment life ascended from simplicity into complexity. From tiny forms barely visible to the naked eye, the oceans transformed into bustling worlds filled with predators, competitors, and bizarre creatures that would never appear again. But one truth remains. Every living thing today is the child of Cambrian wonders. In the gentle darkness of the ancient night, when Earth's temperature began to stabilize and life found its new rhythm, the oceans became the grandest stage for a silent revolution that would forever shape the future of this planet. That era was the Devonian, a time scientists often call the Age of Fishes. Beneath the surface of waters that appeared calm, life was preparing for a great leap forward. If earlier oceans were home only to simple creatures, in the Devonian, everything changed. Life forms became bigger, faster, smarter, and far more ferocious. Evolution moved like an arrow shot from a bow, swift and unhesitating, creating beings that dominated the aquatic world for millions of years. And tonight, in this bedtime journey, we will descend into the depths of that ancient sea, a world where giants swam,
where the first lands turned green, and where one of the boldest decisions in the history of life was made. The decision of some creatures to leave the water forever. The ocean that was no longer silent. The Devonian seas were nothing like the calm blue oceans we know today. Their waters were sometimes murky, sometimes clear, filled with plankton that bloomed like flowers and rich with oxygen thanks to the rise of ancient mosses and algae. Sunlight pierced the shallow depths, creating a dazzling world of blue and green. It was here that new rulers were born. Fish that once measured only a few centimeters evolved into massive bodies with armored scales, powerful jaws, and thick muscle. Predators emerged in forms so extraordinary that modern scientists still struggle to believe such animals truly existed. One of the most famous giants was Dunkleosteus, a creature nearly 10 meters long with a head encased in natural plates of armor. Instead of teeth, it possessed sharp bone blades, capable of slicing prey like swords. Its jaws could snap open with a speed that surpassed many modern predators. In an instant, it could vacuum large prey directly into its mouth. When Dunkleosteus passed, schools of small fish scattered like dust blown by wind. It was one of the first true giants in ocean history. Yet it wasn't only armored monsters that dominated. In this era, true bony fish began to flourish. They had more flexible fins, lighter bodies, and speeds that allowed them to maneuver with elegant precision. On another evolutionary path, a unique group of fish emerged, lobe-finned fishes, destined to one day abandon the ocean and change history forever. When land began to turn green, while life in the oceans was exploding with diversity, the land began to change slowly but steadily. Once barren and dry, the ground was now decorated with mosses, terrestrial algae, and small plants only a few centimeters tall. From afar, the land did not appear green like today, but flecks of color were beginning to appear, hints of new hope for life. This shift was driven by two major innovations. One, the emergence of simple roots that allowed plants to anchor themselves and store water. And two, the development of primitive nutrient transport systems that enabled plants to grow taller. For the first time, the land was no longer silent. There was life, simple, fragile life, struggling to conquer a harsh and unforgiving new environment. These small plants formed colonies, eventually creating tiny green meadows around lakes and streams. Traces of life spread in all directions, like a painting slowly being filled with color. And the presence of plants opened new opportunities for animals. The first land creatures. With plants beginning to spread, the land became more humid and shaded. Soil that had once been barren now housed ancient fungi and early invertebrates, such as prehistoric cockroaches, giant centipedes, and primitive scorpions. Some grew to sizes that would make modern humans shiver. There were giant scorpions reaching the height of a modern human's knee. There were centipedes nearly 2 meters long. There were massive arthropods crawling slowly through the morning mist. But these were not the true rulers of the land. They were pioneers, the first settlers. The real rulers were still preparing in the water.
the fish that decided to try something new. In the beds of shallow rivers and lagoons lived a group of fish destined to change everything. They were the lobe-finned fishes, with strong fins containing internal bones, almost like the beginnings of legs. Their environments often dried suddenly. Shallow lakes shrank during the hot season. Rivers could turn into hot mud, leaving fish trapped in shrinking pools. Under these harsh conditions, some lobe-finned fishes began developing special abilities. They could use their fins to support their bodies. They could make short crawling movements over mud. Some developed primitive air sacs, the earliest forms of lungs. From these adaptations emerged Tiktaalik, one of the most important creatures in evolutionary history. Its body was part fish, part reptile. It still had fins, but those fins could function like tiny legs. It could lift its body from the mud to breathe fresh air. Here, for the first time in Earth's history, a creature gazed upon the world from land. Though it rose only a few centimeters above the water, that tiny movement changed everything. From Tiktaalik's simple act would arise amphibians, reptiles, dinosaurs, birds, mammals, and eventually humans. All of that began from a small fin daring to try something new. The beauty and brutality of the Devonian Ocean. The Devonian seas were not only home to giant predators, they were filled with breathtaking beauty. Green algae formed vast underwater fields. Large sponges decorated the ocean floor like early coral gardens. Colorful fish swam among forests of ancient seaweed, creating a diverse ecosystem in the shallow waters. But this beauty did not erase the brutality. One ancient morning, a small group of bony fish swam peacefully, enjoying the sunlight filtering through the water. But within seconds, their peace became a nightmare. A massive shadow emerged from the depths. Dunkleosteus shot upward like a colossal arrow, devouring a large fish in a single bite. Its jaws crushed the prey into fragments, scales scattering like shattered glass. Blood slowly clouded the waters around them. Elsewhere, young lobe-finned fish hid under submerged logs. They lived in constant fear, avoiding large predators that prowled nearby. Yet this fear forced them to become smarter, faster, and stronger. Evolution never stops working. The land begins to breathe. While the oceans hosted colossal predators, the land gradually transformed into a new ecosystem. Plants, once mere patches of moss, began to grow taller. Some species rose like small trees, 2 meters high. They developed primitive hard stems that gave the structure to the land environment. Among these plants, early insects flourished. They crawled, hopped, and some even attempted to flap their simple wings. The land was no longer silent, no longer empty. For the first time, sound existed. The whisper of wind brushing past plant stems, the rustle of insects, and the soft breath of damp morning air. This was a new world, one that would soon host much larger land animals. The end of the Devonian and the dawn of something new. No era lasts forever. As time passed, dramatic climate changes struck Earth. Temperatures shifted, sea levels rose and fell, and several minor extinction events occurred toward the end of the Devonian. Many creatures, especially those in shallow seas, did not survive.
But not all was lost. Among the survivors emerged the ancestors who would shape Earth's future. The lobe-finned fishes that successfully walked onto land evolved into the first amphibians. From them, the land would be filled with animals far larger, more complex, and more diverse. The Devonian was not an ending, it was a doorway, an open gate to the true age of terrestrial life. This era left us a tremendous legacy, the courage of life to try something new. And now, as we close this chapter, imagine the vast ancient sea reflecting the first rays of morning light. Beneath the surface, giants swim with power. On a river's edge, a small Tiktaalik lifts its head, gazing at a world no creature had ever touched. The journey toward the future had just begun, and life achieved it with one small step out of the water.